Welcome back to Bite Size Chemistry, where we talk about big chemistry topics and we shrink them down to easy digestible chunks. Today, we're going to go over kind of the last law of gas laws, and that is Dalton's law. And this one's so simple, a lot of times it's not even worth mentioning. And all Dalton's law states is that your total pressure, usually written as P total, is equal to the sum of all your individual pressures. So if you have three individual or partial pressures, you just add them together and they get you your total pressure, right? Now, the key here is to make sure that all pressure units are the same. So they can either all be in ATM, all be in millimeters of mercury, all be in kPa, as long as they're all the same. And then you just need to make sure that you add correctly or subtract. Sometimes they'll give you questions where they give you a total and two partial pressures or one partial pressure, and you have to find the missing. We're actually going to do a couple examples of that real quick. So, first example here. In a sealed research chamber, three different gases are being tested. Oxygen gas exerts a pressure of 22.5 kPa. Nitrogen gas exerts 48.9 kPa, and carbon dioxide gas exerts 13.6 kPa. What is the total pressure inside the chamber? All right, so I'm told that I'm given three partial pressures. I'm given the partial pressure of oxygen gas, which is O2, given the partial pressure of nitrogen gas, which is N2, and I'm given the partial pressure of carbon dioxide, which is CO2. And this is 22.5 kPa. Since 48.9 kPa, and this one is 13.6 kPa. All right, the first thing I'm going to do is I'm going to make sure that all of my um, pressures are in the same unit, okay? So I notice here that they are all in kPa, so I don't have to do any conversions, which is great. So now I just use my Dalton's law equation, which is P total equals all my partial pressures. So P1 plus P2 plus P3 and continue on for however many partial pressures you have. So filling that in, got 22.5 plus 48.9 plus 13.6. And that gets me a total of 85 kPa as my total pressure. So my P total is that. So see, that's super simple. You just got to add. No big deal. Now let's look at one more where instead we're given the total and a couple partial pressures and we have to find the missing. So in a gas mixture used in a high altitude simulation room, the total pressure is 101.3 kPa. The partial pressures of oxygen and carbon dioxide are 19.7 kPa and 0. kPa respectively. What is the partial pressure of nitrogen in this mixture? All right, so let's list what we have. We know that our P total is 101.3 kPa. And we know that's made up of three gases. So we know the first one is oxygen. So the partial pressure of oxygen is 19.7 kPa. Respectively means it goes in the same order. And then we have partial pressure of carbon dioxide, which is 0.7 kPa. And what it's asking for is the partial pressure of nitrogen. Okay. So look, just plug in what you know in your formula. So in my formula, I know I have 101.3 kPa as my total. And I know I have 19.7 plus 0.7 plus an unknown. We're going to call that x. Okay, now just simplify and subtract. So this is still 101.3. Oh, my pen just decided to die. Let's do another pen real quick. 1.3 equals 19.7 plus 0.7 is 20.4 plus x. Get x by itself, subtract 20.4 for each side. So x equals 20.4, 80.9 X is our unknown. So that tells us that our partial pressure of nitrogen is 80.9 kPa. All right, that's it for partial pressures. Remember, hit the subscribe button, and I'll see you next time for another episode of Bite Size Chemistry.